Hi guys, imagine you are trying to analyze a stock returns. You build a regression model using company size, earning growth, and valuations multiple. Everything looks fine, but then you notice something strange. Technologies company consistently trade at a higher valuation than traditional industries. Healthcare companies behave differently from energy companies. Banks had different profitability patterns compared with consumer company. The question is how can a regression model capture difference between categories like industries, regions, or business styles? A normal regression model only understands numbers, but the real world is full of categories. Company belong to sectors, country belong to regions, product belong to different groups. So, how do professional analysts include these informations? The answer is one of the most important tools in regression analysis, dummy variable. Today we will understand not only how dummy variables work mathematically, but also how investors and analysts use them to improve financial models. So before we talk about dummy variables, we need to understand the problem they solve. A regression model is basically a machine that looks for relationship. It asks if it changes how the Y respond. For example, does higher revenue growth lead to higher stock returns? Does small leverage increase risk? Does company size affect valuation multiples? These variables are numerical. Growth rate can be 5%, 10%, or 20%. Debt to equity ratio can be 1.5 or 1 or 2. The regression model understands these numbers, but financial markets are not only about numbers. Many important characteristics are categories. A company can be technologies, healthcare, energies, financial services, food and beverage. The problem is regression equations cannot directly understand the word technologies. It needs number. This is where dummy variable enter. A dummy variable converts qualitative information into a numerical format that a regression model can use. Think of it as translating business characteristics into a language that statistical model understands. So a dummy variable is a variable that represents a qualitative characteristic. A dummy variable is a variable that represents a qualitative characteristic using numerical values. Usually, 0 means the characteristic is absence, 1 means the characteristic is presence. So for example, suppose we want to study whether technologies companies have higher valuation multiples. We create technology dummy. Technology company equal 1. Non-technology company equal 0. Now the regression model can understand the difference. The important idea is the number itself has no economic meaning. The value 1 does not mean 1 unit of technologies. It simply identifies membership in the group. It's a signal, a switch, like turning a light on or off. So now we reach one of the most common concepts. Suppose we have 5 industries. technology, financial service, healthcare, energy, food and beverage. A beginner might think, why don't we create 5 dummy variables? The answer is because it creates a problem called perfect multicollinearity. The regression model does not need on categories. It only needs enough information to compare groups. So for 5 categories, we use n minus 1s. 5 minus 1 equals 4 dummy variables. We select one category as the base group. This is called the reference group or the control group. In this example, food and beverage become the base group. The regression coefficients for the other industries tell us how those industries differ from food and beverage. Let's look at the coding. Technology compare VC. Technology dummy equal 1. On other industry variable equal 0. Financial company receives. Financial dummy equal 1. Everything else equal 0s. The base category food and beverage on dummy variable equal 0. This means the regression intercept represent the expected value for the base group. Then each dummy coefficient measures the difference compared with that base group. This is the key interpretation. Now let's examine how dummy variables actually change a regression model. The first case is when the dummy variable changes the intercept. The model becomes y equal beta 0 plus delta 0 times d plus beta 1 times x plus error. What does this mean? Let image d equal 0 represent group 1. D equal 1 represents group 2. For group 1, the equations is equal beta 0 plus beta 1 x. For group 2, the equations become y equal beta 0 plus delta 0 plus beta 1 x. Notice something important. The slope does not change. The relationship between x and y remains the same, but the entire regression line moves upward and downward. Think about two companies with identical revenue growth. One belongs to technology sectors, one belongs to consumer goods. If the technology sectors receive a valuation premium, the entire regression line shifts upward. The difference is captured by the dummy coefficients. The second situation is more advanced. Sometimes categories do not just change the starting points, they change the relationship itself. This means the slope changes. We include in interactions term dummy multiplied by x. The model becomes y equal beta 0 plus beta 1 x plus delta 1 d times x plus error. When d equals 0, the slope is simply beta 1. When d equals 1, the slope becomes beta 1 plus delta 1. So the category changes how strongly x affects y. So let's use an investment example. Suppose we analyze company growth rate and valuation multiple. Normally, higher growth leads to higher valuations, but investors may value technology growth differently from traditional industries. A 10% increase in growth may create much larger valuation premium for technology company. Why? Because investors believe technology business have stronger scalability, higher margins, greater future opportunities. So the relationship between growth and valuations is different. The dummy interactions term capture that difference. So after adding dummy variable, we need to ask, are these differences statistically meaningful? Maybe technologies companies appear different simply because of random variations. Maybe the difference is not economically significant. So analysts test the significance of dummy variable. There are two common approaches, the t-test and the f-test. A t-test usually examines one dummy coefficient. For example, does technology sector membership affect valuations? The f-test examines a group of dummy variables together. For example, do industries classifications collectively explain difference in stock returns? The interpretation is similar to normal regression analysis. If we reject the null hypothesis, the dummy variable provides useful information. If we fail to reject the null hypothesis, the category does not appear to explain most variations. Regression models are powerful because they help investors understand relationship, but markets are not built only from numbers. Companies operate in different industries, different countries, different environments. Dummy variables allow analysts to capture those different mathematically. The key ideas are simple: convert category into 0 and 1, use n-1 dummy variable. That's why dummy variables are essential tools in regression analysis, financial modeling. Understand them means understand how professionals turn real-world complexity into investment insight. Thanks for watching.